Good morning, everybody. I have some processes that are in self-healing mode at the moment, so I hope you'll take into account I might lose my voice. I do my best. So, some of you may know that over the past 40 years I've been on a kind of a journey as a theoretical physicist and going all the way up to cloud computing, both as a scientist and as a technologist, to understand and sort of, build the future of IT, if you will. It sounds very grand, but at least the future of IT infrastructure. It's been my topic for many years. To be a good scientist, I've tried to make sure that we understand what we're doing. We're using theory to explain things and dig down deep into the details. To be a good technologist, I've tried to make sure that we create safe and stable and reliable tools that improve our capabilities, but also our quality of life, right? Because we have to work in this industry. But it turns out that balancing these capabilities and safety is a lot harder than we might think. So I'd like to tell you a little bit about what I've learned. To understand why, I think we have to think a little bit about the history of tech alongside the human journey. Changing humans, turns out, is a lot harder than changing technology. You may know some of this. The timeline here shows, well, my journey at least, from the beginning, the early days of mainframes. We've come all the way through personal computers, mini computers, arrival of Unix. Then we had virtual hosts, KVM and Zen kernels allowed us to, VMware of course, allowed us to do virtualization. This red line in the middle, I think, is one of the most important points in that history, and that was the arrival of e-commerce. Right? So we had the web, but then people figured out how to turn this into a business, how to make commercial applications out of the web. And this resulted in a huge change in the industry. So, what this picture kind of shows is that systems have scaled in the similar way that human settlements scale, right? We start out with a single house, a human homestead. We have villages and then towns, and then we build cities. And now we have cities of people and humans working together. And when we start small, when we have just a single homestead, we develop our skills by hand. We do everything, DIY. We fix everything ourselves. We go in and we change things. We need to have all the skills by ourselves. But as we grow into a village, then we maybe have a specialist carpenter and somebody doing the horseshoes, a smith, and so on. And we specialize into roles. And then when we become a city, we have whole job descriptions and HR departments and all of that stuff. So the way that technology develops parallels the way that humans develop. But finally, it's only when a job becomes really tough or dangerous for a human, or a human perhaps can't be trusted, or maybe isn't fast enough, that we try to automate something. And automation has really been my challenge, if you like. In the 1990s, I was involved in what you might say was the automation movement, introducing like factory robots, but software, not hardware, into the management of servers and software. Automation basically started out as a bunch of ad hoc shell scripts, right? The Unix guys gave us tools to script things, and we create these elaborate scripts. But these eventually become impossible to manage because, especially in the 90s when there were like dozens of different kinds of Unix, not like today when we only really have Linux, then it was much more complicated than it is today. And I developed CF Engine, which kind of showed how to apply declarative self-healing to these systems and establish the context in which decisions could be made. And then I suppose what we'd now call AI, alongside cybernetic principles, tried to stabilize these systems and make sure that they were running in a stable mode so that a single person could control tens of thousands of servers hands-free. That was the goal. And it worked. We did quite well. But when e-commerce came along, red dots, we created the need for thousands of new jobs, right? So we grabbed every school leaver and their dog into the IT industry, taught them how to program, and threw them at the systems. And of course, we didn't pass on all that knowledge that we'd learned, all the wizardry and the skills of those specialized roles. We couldn't possibly pass it on to so many people, so we lost a lot of that experience and a lot of that knowledge. And it was a major reset about how we do system management. And there was almost a rebellion against the machines, the automation that we created, and IT went back into this more hands-on kind of age in workers from self-service, from self-healing automation to a more of a kind of self-service management. But now using these power tools like Ansible and Terraform, which kind of take away a lot of the automation and give it back a more hands-on kind of experience. Throughout this journey, the major principle that people clung to was to give people an easy life. Yeah, cognitive simplicity. It wasn't really about control or safety. It was more about our simplicity, our human simplicity on a daily life. One program, one task, modularity, microservices. This is all about working around our human limitations. How much can we cope with in our sort of work-life balance, if you like. So for me personally, this big shift was to stop thinking about systems as fire and forget, throw them over the wall, finished goods, and to think of them as gardens to be maintained. Because in the old days, servers had to be up for months and weeks and months and even years at a time. It was a matter of pride if you could keep your server running for a year or more. Now we don't care about that because everything is disposable. But we still need to have long-term relationships with systems, even if we don't need to have long-term relationships with individual hosts. And CF Engine was designed as something like the AI gardener of the day, something like the autonomous self-driving cars that we thought we would have. Not like today's AI, which is based on random generation from massive data sets, training sets. It was designed to follow human policy. So humans would decide the direction, what they wanted, and then the system would converge like GPS coordinates almost to this desired state target and fully implement that. So that literally one person could run 100,000 machines. And this, of course, is how the immune system reasons. The immune system is the second most important reasoning system in our bodies after the brain, at least for most of us. Mine is currently working quite hard, probably better than my brain is at the moment, but well, let's not get into that. 10 years later, Google's cloud engine, Borg, which my friend John Wilkes worked on at Google, applied this kind of healing approach, the scaling approach, to on a much faster timescale to develop the infrastructure for Borg, what we now call cloud, on-demand services. Because CF Engine was designed for a much slower age, it could do a lot of the things, and it can still do a lot of the things that cloud does, but it was designed to work much too slowly, so it needed to be refactored. And this, of course, was only possible due to virtualization. And this inspired Kubernetes, long story short. But one of the things I think is interesting is that one of the key things that came out of this is that a lot of these issues turn out in the form of language problems, how we represent our intentions. And CF Engine designed a kind of domain-specific language around this to really simplify the way we express ourselves. And now, with the kind of revolution, the throwing away of old technologies, the e-commerce, we've thrown away a lot of those languages as well and gone back to YAML, thinking we could just start out with a few simple declarations. I mean, how hard could it be to set up 10,000 machines, right? But then what always happens increasingly is that the complexity comes back through the back door just when you're not expecting it. You need to add a thing because you forgot about something, and you keep adding, and you keep adding, and eventually that simplicity becomes complex again. At the moment, there's no people shortage really, in the IT industry in terms, as there was during the e-commerce era. So cloud brings us back full circle with much more manual-oriented tools, and people are much more involved in the running of the system than they were during those days. But then the mid-2000s, there was this great optimism around the idea of infrastructure as a service. Let's make ourselves a kind of help-yourself supermarket for IT, just pick everything off the shelf, download it, get going. Virtualization and cheap storage made all of this possible. And you know this song by Joni Mitchell. It was all beautiful flows of angel hair and ice cream castles in the air. But as the song goes, we've also seen that there's a darker side to this now as well. The innovation and progress that was apparent in the early days is now often blocked by cloud providers. And some of the innovation slides backwards as we turn what we maybe thought was the best technology back into something more like what we had before because it's more comfortable. Again, the human influence on this is quite prevalent. So there's good and bad involved in the cloud transition. So for a bit of fun, let's try and understand some of this in terms of pop culture. A few apart from Joni Mitchell, there are a few other sort of references to cloud in popular culture. This one, anyone know this film, Cloud Atlas? It's a book, a film. Nobody seen it? Oh, okay, like 1.5 people. Well, this made a sort of a simple point, obvious point, maybe a bit cynical. Here the message was that humanity can become anything. The cloud in the Cloud Atlas was humanity. It could become anything we wanted, but in the end we kind of always turn out the same. And no matter how much we change, we always turn out the same. Plus ça change. So at the root, humans are the issue. We have met the enemy and he is us. And what I think we've seen is this huge shift. If you look at conferences in IT, there's been a dramatic shift away from discussing the technology and how we build systems, the principles, towards how we as people get along together, how we work in teams, DevOps, from core technical issues to social justice. And I think that's an interesting observation because it means that the human element of the human computer system is now the dominant factor in the way we build technology, which is perhaps to be expected as we integrate it into our lives. And what we call DevOps is high on the agenda. This one you must know. Star Trek fans? Oh, come on. Come on. So the cloud city of Stratos in this episode, floating above a mining complex, sort of portrays the inequalities that technology brings. Those who can afford to float above the clouds, the bankers, they live up in the clouds and they look down on the people doing the work with their pickaxes and their manual tools. And we once thought that infrastructure could be a leveling effect on society. It could be a leveling force in the industry, making everything cheaper for everyone. But of course, it's a bit naive. It never really happens that providers pass on all their discounts to their customers. They like to increase the prices. And then there's Jevons law that tells us that as things become more efficient, people want more of it. So, the total amount, the demand is increased. So as long as big money sort of drives the pace of change, there will also be a class society. And there's been this backlash against replacing smart automation using these, what I call, because I invented this smart automation, when people use these pickaxes like Ansible and Terraform, it annoys the heck out of me because it feels like we've gone backwards 20 years. But I'm not going to complain to you. But I think these things are sort of important because they're potentially dangerous when we put mission-critical systems in the hands of humans that can make mistakes. Just look at recent events like SolarWinds, massive rollouts performed by hand that we sort of blame our tools for. And then it leads to, then we blame it on complexity. So number 3 is complexity. Kinto. Anybody Dragon Balls fans? Oh, a few more. Really? I'm really disappointed that there are more Dragon Balls fans than Star Trek fans. You know, we sometimes get into trouble because we feel the need to keep things as simple as possible. It's one of those mantras we have, right? This is Goku from Japanese anime Dragon Balls, one of these reimagined Journey to the West stories. Kinto is a magic cloud that only the purest of spirits can ride. And so Goku is a very simple person. He's much too kind, he's compassionate. Just when he's about to beat his enemies, he always takes pity on them and says, "Oh, I'll let you go," and then they always come back and hurt him again. And this tends to happen to us as well. We make systems too simple when we raise them in captivity, and then we release them into the wild where things are much more complicated. We didn't plan for all of those complications initially, and then we have to tweak them, add to them. Before we know it, everything is much more complicated than we planned. So our human conceit, actually, is that we can make things simple, and we think we can make them simpler than they need to be. And I think this is also reflected in the way we treat them in terms of language. I mentioned the YAML thing before. We think we need a special vocabulary to describe our system, so we redesign things in terms of streamlined languages, simple declarations, simple keywords. But then we find that as things get more complicated, that vocabulary grows, and the language evolves, and suddenly it's complex again. And so the next person comes along and says, "Oh, they did it all wrong, these old idiots. We need to replace it by something new," and they replace it new, and they make it too simple, and then it happens again. And they say, "Oh, they didn't know what they were doing," and they replace it again. And we've seen this cycle continue, currently sort of in a YAML phase, but I think the lesson here is that intent is simple. What we want may be simple, and this is where promise theory comes in. That's what I tried to capture there. But what we want, our intent, is the tip of an iceberg, right? So compared to what can actually happen, which is what we need to think about, what we need to model. And it's an important reality check. You know, as that other famous popular culture guy, Mick Jagger, said, you can't always get what you want. Here's another Star Trek one, sorry. Still on the complexity theme, you may know this story though, right? The old Voyager probe goes out, gets refactored by intelligent machines, comes back in search of its creator. This is what simplicity looks like after 300 years of pull requests and bug fixes with an AI-enabled cloud software around it. You know, if cloud comes back to us in the future looking for its creator, I wonder who it's going to pick on. But there's a serious point here, which is that our systems do kind of get out of hand if we don't focus them on clear objectives. You know, remember the internet worm, remember solar winds, remember BGP black holes, if anybody is networking folks. You know, these are things that still hurt us on a regular basis. And what happens is, as time goes by, we pile layers upon layers of software. I remember when I started computing, we had, some BBC Micro 6502 processor. Since then, CPUs have grown 3 to 4 orders of magnitude in speed, right? 10,000 times faster than they were back then. But software is about the same. That means we've lost 4 orders of magnitude in speed and efficiency in software, just to some layers of software, which we would like to have back, please. So keeping it simple turns out to be dangerous because it means that we just sort of naively layer things without refactoring, without rethinking. When we bug fix, all we're doing is a kind of a gradient search for correctness in a landscape of sort of local minima, and we may find an area which is less unstable than this bit, but we don't necessarily find the best possible minimum or the best possible optimum system. So what I think we can do as we build systems, and what we need to figure out in our sort of modern cloud-oriented culture, is how to build in safeguards that respect human life and dignity from the beginning. while putting in enough levers for humans to pull, because we need to control the car, right? We don't want the car to just drive us around. We still want to be involved. We like pushing buttons, and that's what our hands were designed for. So we need to figure that out. So last example, and sort of the conclusion of all this is, this goes back to British composer Gustav Holst. Doesn't sound too British, right? But he had complicated ancestry. He wrote this beautiful piece of choral music, which you might like to check out afterwards, called The Cloud Messenger, based on some Sanskrit poetry. He worked very hard on it and released it out, performed it, and the audience didn't like it at all. And he was really disappointed. It was 77 years before he played it again. But it led him to rethink his approach to composition. His next piece, The Planet Suite, of course, is one of the most famous and well-known of all. But here I think the message is the human story again. We may have a beautiful vision for what we think is the future, what we think is the best technology, the best approach. But in the end, it boils down to the audience. Will the audience accept it? And this is what we've seen in tech throughout that timeline that I showed you. Time and time again, new ideas, good ideas have been rejected by people, and we've gone back to the thing we had before with some new dressing. As the album, another pop reference, same shit, new wrapping. This is how we kind of design things. So one side of us hopes to return to a simpler life, while the other one wants to explore tech as the ultimate computer game. We struggle with our own role in the system. But civilization, human civilization now, again going back to the timeline, that was built on the depersonalization of systems, taking our individual concerns out, and as Spock said in Star Trek, the needs of the many outweigh the needs of the few. So we try to build things that are good for everyone rather than for individuals. But tech is reversing that because it's giving us more power to individuals, and it's turning the tech world into a more tribal world. You know, our T-shirts say who we support, which team we support. The teams often get a bit stroppy with each other. There are all kinds of discussions on Twitter and so forth. So we need some guardrails in the human process as well as in the tech process. So enough fun, let's be boring again. Can science help? Science is my day job, if you like. It's what I started out doing. It's about having rational answers. But it's not about just what we want. We need to combine what we can have, the dynamics of a system, with what we would like it to mean or how we would like it to work, the semantics of the system. So dynamics and semantics, change and meaning. These are important limits. We can't just software the heck out of everything and hope to get it right. We'd like to have some direction in this. And of course, we're in Copenhagen, right? So let's not forget that it was the Danish astronomer Tycho Brahe who provided the data for Kepler to figure out the orbits of the planets. You know, so I have high hopes for you guys. You're going to figure it out. Science shows us that systems are full of beautiful structures and subtle ideas. On the slides, you see some nice pictures that I included for effect. We can study that. Like, we can study the patterns and say, what can we learn from this? And this is where, you know, promise theory comes in. It's about asking scientific questions. And some of those questions are what led me to invent the self-healing systems. And the scaling theory shows us, for example, that we can do networking better. We did load balancing wrong all these years. Why can't we get that right? Let's not even get started on why we can't do data consistency right between all the microservices and so forth. Should we centralize or decentralize? All of these issues can be discussed in a scientific way. Sometimes science asks questions in weird ways. So the picture I put up on the slide is from a study I did where I asked the question, what is the dimension of the internet, the spatial dimension of the internet? You probably heard that string theory believes that we have 26 dimensions in the real world, and we can't see all of them because they're too small. Well, we can ask the same question for the internet and actually measure it. I actually measured it. And it turns out that the internet has between 6 and 255 dimensions. And it sounds like a weird thing to ask, what the heck does that mean? But it turns out that it's just a funny way of asking what is the routing path redundancy of the network. If starting from a particular point, how many independent routes can I take to get to where I'm going? And that depends on scale. So yes, funny example, but it shows that we can actually make progress answering deep questions using science as well, and we need to turn this back into technology. Sometimes that comes out unexpectedly, because even if we want to control every aspect of a system, we can't. And the reason we can't is that there are constraints and there are dependencies involved. I don't have to tell any of you about dependencies. This grows worse, of course, in proportional to scale. And as we scale things, they tend to become more complex. And that's why I think it's one of the reasons why we tend to build smaller clusters and microservices, because we're trying to contain that complexity in the only way we know how. Because the technology doesn't allow us to control it and scale it, we have to keep it small and rather build several of these things. So if we're having fun again with science now, we can ask from a purely scientific point of view. Actually, before I say that, let me just mention this picture that I put up here since I put it here. This was part of a simulation I did to study how processes move around inside cloud-like systems. And this is kind of an idealized cloud system. But what I wanted to show is that as our systems scale, actually containers start to behave in strange ways. And they actually behave somewhat like particles in a quantum field. Again, that sounds like a strange idea, but less strange when you know more about it. And it turns out that they interfere with one another, and they interfere with one another because they have common dependencies, and the isolation between processes isn't that good. So we could also speculate about this, right? Well, having asked that question, there's now a fun part to that question, which is, what if the universe as we know it is actually much more like our cloud computing systems than we realize at the fundamental level? And the way that the quantum world works is actually somewhat computational in its formats or in its origins. So that's an interesting thing. We may enjoy asking questions like that, or like Holst, the audience may reject them, but we can still apply science to these questions. All right. Cloud presents us with these enormous opportunities, and it's given us this game-changing ability to change infrastructure in the world. But in a way, all we've done is to slip some old ideas into virtual clothing and come up with the same thing again. If you'd like to read more about what I've told you here, I have a few books on this subject. I made a little histogram of them here. You see the vertical scale is readability. So as you go to the right, it becomes less and less, but you're not afraid of pain, right? Otherwise, you wouldn't be doing Kubernetes. The principles we know for scaling, safely scaling intent, are not always built into our software today. It's important that we understand our intent, what we're trying to get to. The principles of CF Engine, I think they're still valid today, but they need a new wrapping. That the original wrapping was for a different era. Even Kubernetes needs a bit of an overhaul today, let's face it. We need to keep going back and checking the basics. And unless we can build on theory and experience as we go along, and build in the human experience as part of that, we won't get these advances in technology. Our modern age is a human-computer civilization. This is us. And like human civilization, when it gets big, certain freedoms that we take for granted on a small scale scale poorly. We need to be more disciplined as we get bigger. We need to be more, rigid to some extent. We certainly can't be spending our time on Twitter arguing about whether there should be commas at the end of a list or not, which is, a lot of what happens in tech these days. So we might yet ride our clouds to the stars, but only if we settle our human concerns first. Thank you for listening, everybody.